Greetings, welcome to Patch a Day number 3, I think 4 maybe. Yeah, this is 4. Okay, I'm going to make an object dance around according to sound input. I guess I'll start with my sound input. I'm going to use an SF play. This is the sort of thing I've done a million times before. SF play, and I'm going to make a message where I'm going to open something that we've used before in these in my tutorials, and open jongli.af AIF comma, which is to separate out this message into multiple bits, comma 1, comma loop 1 so it loops, and then comma 1 so it starts playing. We're going to hook this up and already just stick it out through a DAC in case we want some background sound to enjoy while we're making this thing. Wow, we've heard that before probably. The objects that I'm going to use in jitter are to create the shape. I'm going to use jit.gl.grid shape, and I'm going to give it some arguments as well. The first argument, which you always need to have in a GL object, is that always? Okay, is the name of the render destination, and I guess we'll call the render destination shape. And it also needs to give, if you want it to have a certain shape, let's have the attribute @shape and call it a cylinder. I decided the cylinder would be a great shape to use for this one. We also need then our render destination, which is a new object, jit.render, is where we're, is this called gl.render, sorry. Is this the destination? No, this is just the actual rendering. And again, the destination is called shape. The actual destination, which is going to be called, is going to be the jit.window. We'll give that the same argument, shape. So there's our window that our groovy looking images should come up on once we've got them going. Alright, you've probably seen, if you've looked through the jitter stuff already, the kinds of things we need to do to get the jitter stuff working. It always needs a bang, so we use a metro of 20 milliseconds with a toggle to turn the metro on, and then a trigger object, bang, then the message erase is going to make it so that this render object actually erases every frame before it draws the next frame. If you turn off, actually, if you get rid of the erase on those on the render, it can create some very interesting stuff, but it's just like turning down the alpha down to 0, if you like, as well. Okay, I suppose I'm going to put my camera somewhere for this. We'll stick it out on the Z plane somewhere. And we'll also want to give it light, so, and the light position, I could have copied this all from some kind of, we'll put this out on the, I don't know where that's putting it. Well, who cares? And I need to click those messages if I want them to actually do something. Okay, so to do the analysis, or to analyze this SF play output, I'm going to use something here, a new object called FFFB, which is the fast fixed filter bank, which, say that 6 times fast. I said 6 because I just put that number in there. 6 is for the number of filters that I'm going to create. 50 is for the frequency of the lowest filter. H is for the, so that they're in the harmonic series, so they're going to be filters at 50, 100, 152, is that right? Yeah, 250, 300, etc. hertz going up. and then some number for the Q, which is, as you probably know from your extensive reading, is the sharpness of the filter, or the width of the filter bands. Okay, a higher Q just means that the filters are narrower. Then I'm going to use a bunch of average objects here. This is going to look a little tedious, but let's just start with one. As you probably, if you've been doing enough maxing by now, you'll probably know it's a good idea, if you've got multiple copies of things, to either create some kind of abstraction, as I might call it, or at least build just one so you can duplicate it. I'm going to take my average, multiply it by something. I've got 50 in mind. And then I'm going to, well, let's just backtrack for a second. What I'm actually going to put these through for the grid shape is I'm going to make it so that they change position. I'm not sure if the help on grid shape gives you this. Oh yeah, it does right there. So the help on grid shape has the position thing. I'll copy that. So that'll be the position in X, Y, and Z, and I'm going to use that position. And I'm also going to use, I'm going to change the positions of them, and I'm also of the objects, and then I'm also going to rotate, which I don't have one here. Rotate works a little bit differently to position in that rotate has 4 values, expects 2 values. The first value is the actual rotation amount from like 0 to 360 degrees, and then the next 3 is how much on each one of the X, Y, and Z planes that rotation is applied to. It's a bit complicated maybe. Anyway, so I'm going to change the position and the rotation of this grid shape. That's what I started building up here, is something to change at least positions, and then to make them so they move, so it moves kind of slowly. I'm going to pack these, this position. This will be my X position. I'm going to pack it into a line and have that line. Make sure that it's a floating point line, and then give it a sort of a period for the for it to spit out numbers. So that's going to be my position output there, taken from an average from the filter. We'll also want to bang this average, which we could do every time we get an output tick of our metronome, but since we are putting it through a line here, it doesn't make any sense that we would do it for every 20 milliseconds if we're going on a 20 millisecond line. There'd be nothing for the line to do. So I'm just going to have a counter of, let's say 10, so this happens every 200 milliseconds maybe, and then I'll trigger those average analyses every 10 clicks of the metronome, and that's where the select 0 comes in, as when the counter reaches 0, it'll bang that average out. Okay, I'm still running out of space here. Okay, let's go down here. I'm just going to duplicate this some, so we'll do this for the Y as well. We just connected that wrong, and I'll do it also for the Z. Yeah, like I said, making a doing something where you would encapsulate these somehow, even if you did like N for new patch and P, we'll call it Jivo, and we can at least like stick these, stick this into Jivo and make our life a little bit less messy looking. A couple of inlets and outlets, just one inlet, one outlet. Alright. Okay, so Jivo is a little less cluttered than this other stuff. Rotate. That's the amount. So and these are the axes. So we'll just do gyro on the axes. We're going to have to hook up the bang to output all these averages. And there's that, and bang that one, and bang these. You'll notice that the inlet goes into the average as well as the signal, so that's fine to do that on those sub patches. Alright, so now we should have something that looks like something. Where's our window? Double click the window to see it. You'll see that didn't look at all inspiring, perhaps. To make it look a tiny bit better, one thing we might want to do is, I'm opening up the grid shape help here. Let's have it so I can change it. Alright, so I'm going to use these values down here, and as you'll see, those are connected to, actually I'll take that one as well. Depth enable, smooth shading, and lighting enable will actually make this thing look slightly more attractive. Find somewhere to stick those. Yeah, okay, fine. And those will want to go into the grid shape object, so I'll use their word, grimy. I'm sure that means something to someone. Click the one to activate that, and then it'll at least look well, that still looks a bit naff. Yeah, from my experience, GL stuff in Maximum SP Jitter doesn't look all that awesome. If you're looking to do, if you're doing into the sort of visual side of things and you're looking to do more, there's a program called it's called Touch Designer by Derivative. You can get there by just typing in derivative.ca. It's a visual-based programming environment, very much like Maximum SP. It comes with a ton of really amazing visual processing objects and a whole lot less audio. So it really doesn't do anything much with audio. But if you're interested in doing visual work, it receives and sends OSC, so it's easy to make it talk to Maximum SP. For the visual side of things, I think it just looks a lot better than Jitter, but don't get me in trouble and quote me on that one. Alright, cheers.